Hi everyone, in this video I'm going to go over a stoichiometry example problem. If you're in my class, this is number 1 on your test review. If you're not in my class, you can pause this video and write this problem down. This is the problem I'm going to be working through. It's a pretty common stoichiometry example. So let's get started. The first thing you need to do with any stoichiometry problem is write a balanced equation. It might not be given to you in the problem. If it is given, make sure it is balanced, but if it's not, you have to write it. And so I'm not going to go into much detail on how to write formulas in this video. If you need help with that, I have other videos that you can watch. So this reaction is between dinitrogen pentoxide. Dinitrogen, that would be N2, pent, like a pentagon, 5 sides, so O5. And water, H2O, that will form an aqueous solution of nitric acid. So nitric acid is my product. Just a quick review on acids. If there is not a hydro in the acid name, like hydrochloric acid, like this one is just nitric acid, that tells me that there's an oxygen in the formula. Now all acids start with H, and then I need to look at that part that says nitric. There is a saying, I ate something icky. You ate something icky. So when the acid is an ick, like nitric, it means it comes from the polyatomic ion 8. So it comes from nitrate. Now nitrate is NO3 -1. And this is an acid, so it starts with H in front, which has a charge of +1. So the formula is HNO3. And then we need to balance this equation. So there are 2 nitrogens on the left. I'm going to put a 2 in front of nitric acid on the right. And then now there are 2 hydrogens on the right, and there are 2 on the left. That's perfect. And then oxygen on the left is 6, because there's 5 here and 1 here, and there are 6 over here. So this equation is balanced, and we can start the problems. So part A says how many grams of nitric acid would be made from 0.8874 moles of dinitrogen pentoxide gas. First thing we're going to do is just write my equation down at the bottom so we don't forget it. And then let's look at what we are given. So 0.8874 moles of dinitrogen pentoxide gas. So anytime you do stoichiometry, you always start the setup with the number that's given to you in the problem. You don't ever start with a conversion, you start with the number that's given to you. So 0.8874 moles, we can abbreviate MOL, into O5. And we want to find grams of nitric acid. So when you start a problem with moles, like this one, you will immediately go to your balanced equation and look at the coefficients. The coefficients in your balanced equation are known as the mole ratio. That's the ratio between reactants, products, and mother products, reactants and reactants, etc. And so my coefficients are a 1 in front of N2O5 and a 2 in front of HNO3. And so I'm going to use my coefficients in this first step because I started with moles. If I didn't start with moles, I wouldn't use the coefficients first. I would use them second. And so the coefficient for N2O5 is 1. So down here, that's a 1 mole N2O5. I put the N2O5 at the bottom, so that way the mole units cancel out. And then up top, I'm going to write 2 moles HNO3 because the coefficient for HNO3 is 2. Perfect. Now, the question didn't want moles of nitric acid, it wanted grams, so I'm going to need another setup. So to get grams of any substance, you have to go to your periodic table, and you look at the formula. So the formula of this is HNO3, and you go to the molar masses, which is the bottom number. For hydrogen, the mass is 1.008. For nitrogen, the mass is 14.007. And oxygen, the mass is 15.999. Now in this formula, there are 3 oxygens, so I'm going to have to multiply that number by 3. And then you just add all those numbers up. And when I add those numbers up, I get 63.012 grams. And that's how many grams are in 1 mole of nitric acid. And so I will put that conversion next. Now, it's important to note, where do we put things? Because I have moles of nitric acid at the top, I want to cancel the mole unit out. So at the bottom, I'm going to write 1 mole HNO3, and I write the molar mass, or the grams, at the top. 63.012 grams HNO3. Now, a common mistake is a lot of people right here will write 2 moles HNO3 because it's a 2 in the equation. The only time you use your coefficients is in the mole ratio, this step right here. Otherwise, it's always 1 mole. This step is the only time you use coefficients. And then we can solve this problem. To solve this problem, when you do stoichiometry, you multiply everything across the top together. So I'm going to circle that in green. So you multiply all of those. The 0.8874 times 2 times 63.012. And then you multiply what's at the bottom together, which is just 1. And then you divide. So it becomes the top divided by what's at the bottom. But you need to multiply everything together first before you start dividing. And so the answer is 111.8 grams HNO3 as our answer. Okay, and that is how we do question A. Let's move on to B. So how many molecules of water are needed to produce 0.874 moles of nitric acid? So really fast, I'm going to write my equation at the bottom for us to reference. And let's get going. So this time we want to find molecules of water, and from that many moles of nitric acid. So you always start your stoichiometry with your given 0.874 moles HNO3. Now I'm starting with moles again, so my first step will be to use my mole ratio, which is my coefficients. So this problem, the coefficient for nitric acid is 2. So I will write 2 moles HNO3 at the bottom. That gets rid of the moles of nitric acid unit. They will cancel out. And that equals, we're looking for water, so 1 mole water up top. Now that I have gotten rid of nitric acid and I have water, I can go back and look at the problem. I want molecules of water. Molecule is Avogadro's number, which is 1 mole of anything equals 6.02 times 10 to the 23 particles. And particles are the same thing as molecules, atoms, formula units. So we can use this conversion. Now we need to cancel out the mole unit, so I will write 1 mole of water at the bottom, and then put Avogadro's number up top. 6.02 times 10 to the 23 molecules, which we can abbreviate MLC, water. Now, once again, I've canceled out mole unit. I'm left with the unit molecule water, which is what I wanted. And then to type this in the calculator, you multiply all of this across the top together first. So 0.874 times 1 times 6.02 times 10 to the 23. And then you multiply what's at the bottom, so 2 times 1. And then you divide. So top multiplied together, bottom multiplied together, and divide. And be really careful as you type this into your calculator, because scientific notation can sometimes be a little bit tricky. And you should get a final answer of 2.63 times 10 to the 22 molecules of water. If you don't get times 10 to the 22, you are typing it in wrong, and I suggest you go find a video of how to do scientific notation on your calculator. Okay, and then the last question. How much product in grams is formed when 30.7 liters of dinitrogen pentoxide gas react with excess water at STP? So there are a lot of words in this problem that are not trying to confuse us, but can be confusing. So STP stands for standard temperature and pressure. Standard temperature and pressure is 1 atmosphere of pressure and 0 degrees Celsius. The whole point of saying that it's at STP is because anytime you have a gas at STP, 1 mole of it equals 22.4 liters. If the gas is not at STP, that conversion is not true. But this is at STP, so that is a true conversion that we're going to use. And then it says excess water. So we have 2 reactants, N2O5 and water. That I said water is excess, which means N2O5 is our limiting reactant. The amount of product you can make always depends on the limiting reactant. So that's just telling us that water is excess, N2O5 is limiting. Let's say it didn't tell you water was excess, and it said you had like 50 grams of water. You would have to do 2 stoichiometry conversions, both solving for grams of nitric acid, and your answer would be the smaller number. I have other videos that go over an example like that, but that's not what this problem says. This problem says we've got 30.7 liters of N2O5. Now in this problem, unlike the others, we're not starting with moles, we're starting with liters. So I'm going to use this 1 mole equals 22.4 liter conversion first. If you don't start with moles, you need to get to moles, and then you use your coefficients. When you start with moles, you immediately use your coefficients. So this is liters N2O5, which means at the bottom, I need to write my liter unit, so that liters cancel out, and that many liters are in 1 mole of any gas. So that goes up top. Now I am at the mole unit. So liters cancel, boom. And when I'm at mole unit, I use my coefficients. So the coefficient for N2O5 is 1, and 1 mole N2O5 is 2 moles of nitric acid. Now moles of N2O5 cancel out, and we're left with moles of nitric acid. That's not what we want. We want it in grams. And we used this conversion earlier for nitric acid. The molar mass was 63.012 grams. And as a friendly reminder, that anytime you use molar mass, it's always 1 mole, no matter what the coefficient says. So 1 mole nitric acid equals 63.012 grams of HNO3. And then mole unit cancels out, and we can solve. And when you type this into your calculator, again, make sure you multiply the top, multiply the bottom, and then divide. You should get 173 grams of HNO3. So I hope this video was helpful. I have other videos about stoichiometry if you want to see more examples.